let's talk about univariate distributions. So right off the bat, when we're talking about univariate, this means one variable. Univariate, one variable. So a univariate analysis is when you're looking at one variable at a time. So this wouldn't be looking at relationships between variables or moving into anything predictive or anything like that, or statistical significance. This is where we're just describing our sample one variable at a time. And basically saying, well, if we have two variables that we're interested in, then let's look at what those variables look like on their own before we see how they relate to whatever our dependent variable is. So a univariate analysis is just looking at what does my single variable look like for the sample that I have. So there's different ways that we can display our univariate measures, our univariate analyses, and this is through frequency distributions or graphs. And frequency distributions and graphs are both really good for displaying sort of what that variation is and giving a summarized, easy to understand view of each variable. So graphs, you've seen before, like bar charts, pie charts, things like that. It's a picture. It gives you that like instantaneous what's going on with this variable. You can look and you can see. So you can see that if you're looking at something like religious affiliation amongst your sample, you can look and see, all right, well, the majority in this sample is, let's say Christianity, and then there's, a certain proportion that's Muslim, there's a certain proportion that's atheist, there's a certain proportion that's something else. So you can look at that and you can see right away that's sort of what's going on with your variable. And, and then you can sort of, in a really kind of short, quick, easy, not super specific way, but you can sort of try to be like, oh, well, that kind of in general represents our larger population that we're trying to talk about. So if we're coming from an area that we know is predominantly Christian, let's say, then the fact that our sample is also predominantly Christian, that makes sense. And so that can tell us. And then if it's not, if it's really different from the sample, from the population that we want to talk about, if our sample is significantly different, if it's like a really, a huge proportion is atheist, and we're like, well, but is that what our population looks like? And it might not be representative. That's an important thing to know. So that's why these univariate analyses are really important to do before you get too deep into any analysis, so that you know what's going on with your sample and whether it's a good representative sample or not based on what you know about the population, which may not be a lot. If you don't know enough about the population, you might not know whether it's representative or not, and you just have to trust that you've done a good sampling technique. But the graphs are sort of an easy, we can see right away what's going on with that variable, and it gives us that picture pretty quickly. And they have, they're really advantageous because they provide that quick, easy to understand summary. However, another way you can summarize your univariate analyses is through frequency distributions. And so frequency distributions give like the exact number of cases, or maybe a percentage, or sometimes both. It depends on sort of how it's being presented. But it basically provides each variable and then says what's the proportion of each level of that variable. And so you would use these frequency distributions when you have a lot of variables to summarize. So, and sometimes it's good if you want to know the exact percentages and you don't need the pictorial representation, but this is most often used because you have a bunch of variables, and instead of making like 20 or 30 pie charts or bar graphs or something, you just put it into one nice table, and that's what a frequency distribution is. So here's an example, and this is from my research. So this is like real data from my research that I've used, although this is only like a small portion. This is only 10 of the 20 independent variables that I used, and none of the 5 dependent variables. But anyways, so you can look at this and you can see, so they're grouped into types. So like vulnerable victims has 3 specific independent variables under that grouping. Disinhibitors, there's 5 independent variables there. But each line is a separate variable. So you have like victim gender is one line, and so then you can look at that and right away see that the victims were predominantly female, but there was just shy of 20% that were male. So that's something good to know. You can just look at this and know that, If we look at how many used alcohol before the crime for the offenders using alcohol, it's almost 50-50. There's a little bit more that said no, but it's close to 50-50. Versus drugs, there's a lot less that said that they use drugs. So you can like look at this and right away see all of those sort of what's going on with each individual variable that the data has been collected on. So, and you can imagine that if I tried to present bar graphs or pie charts or something about each of these variables, it would like fill pages and pages and it would just not be very helpful anymore. You would lose the advantage of that quick instantaneous information because you'd have to go through so many of them. So that's why frequency distributions are a lot more helpful in situations like this. So to present the univariate distributions. So there are 4 features of the shape of a distribution that are important to talk about. So when you're talking about individual variables still, so we're still talking about one variable at a time, we want to describe that variable. So just saying the proportion at each level is a good start, but there's more that you can say about that. So one important shape or sort of piece of information about the shape is the central tendency. So where is the middle, essentially? And so if we're looking at variables measured at the nominal level, this is when you would use the most common value, versus if you have like more of a quantitative variable, you might want to know what value that the cases tend to cluster around. So the central tendency, we want to see basically where the middle or the most common value is. Then another important measure about the shape of the distribution is variability. And this basically means how much that your data points essentially on one variable, how much they're either spread out or really clustered together. And if this is kind of important because you can look at like where the middle is, but where that middle is, your sample is going to look very different on that variable if everybody is basically right around that middle value or if everybody's really spread out. That's very different samples, and so that's why variability is really important to know about. And then there's skewness. And so basically this is the extent to which cases are clustered more at one end or the other of a distribution of, and this would be more quantitative variables. You wouldn't have skew for nominal level variables, and to a certain extent, depending on how many levels you have, you wouldn't really have variability as either. So these are sort of more for quantitative variables, so something like an age range or something like that. But skewness is basically how much, when you sort of plot all your points, how much it's going sort of to one side or the other. And so you can have a positive or a negative skew. And actually, I am going to bring up paint to kind of show you what kind of skew looks like. So if we have what's called a normal distribution, which is often what statistical techniques have an assumption that your sample is normal, a normal distribution basically looks like that. It's like a nice bell curve where it's, the middle would be here, and, it's about equal spread on both sides. My drawing is not very good, so just bear with me there. But so that's kind of what a normal distribution would look like. Let's just take some of that out of there. So comparing that to a skewed distribution, so you can have positive skew or you can have negative skew. So if it's positively skewed, then it's going to look like that. And so that's because it's called a positive skew, because if this is our number line, then it's skewed, it's pulled in the positive direction. So that's why we call that a positive skew. Versus, versus a negative skew, which goes that way. And so that's because it's being pulled in the negative direction. So people often get this confused. Students get this confused where they'll see, wherever the majority of the cases are, where the bump is, they'll think that that's a positive skew, but it's not. It's where the tail is. It's where the tail is being pulled in the direction that tells you whether it's a positive or negative skew. Okay, so let's go back to our PowerPoint here. Okay, so that's skewness. So then another measure is that we want to talk about in terms of talking about each distribution is kurtosis. And so that's sort of how peaked a distribution is or how flat it is. So you can have mesocurtic distribution, a leptocurtic distribution, or a platicurtic distribution. And so a mesocurtic distribution is essentially that normal bell curve. There is no like peakedness or flatness. It's just that as your typical bell curve. Whereas leptocurtic is what you would call a higher kurtosis, and it's thin and tall with your relatively thick, heavy tails, versus platicurtic, which is a lower kurtosis, and it's relatively flat and more broad with more slender tails. So let me just draw those quickly for you so you can see. And let's get rid of all this business that we don't need. So again, our mesocurtic is going to look like that nice bell curve, a little bit more perfect than what I draw there. But so then you have the leptocurtic, looks like that. And so it's that more peakedness. And then versus platicurtic, which would be more like that. And so it kind of stretches out into longer tails, and it's that flat. And the way I remember the difference between leptocurtic and platicurtic is that plat is flat. If that helps you, that always helps me, sort of, especially when I was first learning the differences. So once you have measures of central tendency, of variability, of skewness, and of kurtosis, that gives you a really good idea of what that curve actually looks like. And so that can tell you, how far from normal are you, and what can you do with this variable, and how useful is it for different types of statistical analyses. Although when you're determining what type of statistical analyses to do, this stuff is important, but the variable's level of measurement is one of the most important determinants. So don't forget about the level of measurement there.